Let's solve the following linear systems. So for this first one over here, we can use the elimination method by multiplying this second equation by 2. So that would give 2x plus 6y is equal to 0. And now if we add these two equations together, 2x gets eliminated, and we get y plus 6y is 7y, and 3 plus 0 is 3. So therefore, y is 3 on 7. And now if you substitute for y in either of these two equations, so let's just substitute in equation 2, we get x plus 3 by 3 on 7, which is 9 on 7, is equal to 0. So therefore x is minus 9 on 7. And we can write our solution as an ordered pair. And I'll leave it for you to check if this solution satisfies both equations. Now in this second example, we have 3 unknowns, so we need 3 equations to solve them. So what we'll do first is add these first 2 equations. So that gives 5x plus y minus y eliminates y, plus 4z is equal to 1. And now what we can do is multiply this first equation by 2 to eliminate y between equation 1 and equation 3. So what we have is 3x by 2 is 6x, plus x is 7x. And then we have 2y minus 2y is 0, and 2z minus z is z. And on the right hand side, we have 2 plus minus 2, which is 0. And now we can multiply this second equation by 4 to eliminate z. So we subtract these two equations, so we have 5x minus 28x is minus 23x. And then 4z minus 4z is 0, and 1 minus 0 is 1. So therefore, x is equal to minus 1 on 23. And then if you substitute this into one of these equations, so we'll substitute into this second equation, we have minus 7 on 23, plus z is 0, so therefore z is 7 on 23. And now we can substitute for x and z into either of these 3 equations. So let's just substitute in equation 3. So we have minus 1 on 23, minus 2y, minus 7 on 23 is equal to negative 2. So negative 2 is minus 46 on 23. So therefore minus 2y is equal to minus 46, plus 1 is minus 45, plus 7 is minus 38 on 23. And if we divide through by minus 2, we get y is 19 on 23. So our solution is an ordered triple. Now for this linear system over here, we can see that the ratio of coefficients of x and y between both equations is the same. So if we divide the first equation by 2, we get x plus y is 7 on 2. And dividing the second equation by 5, we get x plus y is 3 on 5. So we can see that these are the equations of a line with the same slope but a different y-intercept. So the lines are parallel, and therefore we have no solution. Now for this linear system with three unknowns, if we divide the first equation by 3, we get x plus y plus z is a third. And if we divide the second equation by 9, we get x plus y plus z is 2 on 9. And then the third equation is the same as the first equation. So therefore we have the equation of a plane where these two planes overlap. And given that these two equations here are conflicting, then we also have no solution. Now for this linear system over here, we can see that the ratio of coefficients between x and y is the same in both equations. So we can divide the second equation by 7, and we get x plus y is 21 on 7, which is 3. So these two lines have the same slope and the same y-intercept. So therefore, this system will have infinitely many solutions. And for this system over here, again, the ratio of the coefficients is the same in all of these equations. So we can divide the first equation by 2. So we get x minus y minus 2z is 3. And we can divide the third equation by 4. So we get x minus y minus 2z is 3. So as we can see, these are the same equations as the second. So these three are coincident planes. And therefore, you end up with infinitely many solutions.